Hey guys, welcome back to the channel. Today we're going to talk about one of the most iconic figures in the Marvel Universe, Iron Man. Specifically, we'll explore whether his suit, as we see it in the movies and comics, could actually exist in real life. Iron Man was the first superhero to kick off the Marvel Cinematic Universe, a character that made history and won the hearts of audiences all over the world. But the question we're asking today is, could we build a suit similar to Tony Stark's? And what scientific and technological challenges would we need to overcome to make it a reality? Together, we'll discover the possibilities of modern science and technology and see if it's really possible for a person to wear a suit as powerful as Iron Man's. Stay with us for a fascinating journey into the future of science and technology. Welcome to the new format in the Science of the Future. In the movie, Tony Stark is hit by a bomb and some shrapnel lodges in his chest. To keep the shrapnel from reaching his heart, he decides to build a miniaturized ARC reactor. This reactor not only helps protect him, but also powers the very first Iron Man suit, the famous Mark I. The question we're asking is it possible to build an ARC reactor? And what exactly is an ARC reactor? Essentially, it's similar to a fusion reactor. Today, there are two main nuclear methods for generating energy: fission and fusion. But what Tony Stark does is miniaturize this technology and implant it into his chest. But is this really possible? And how close are we to achieving such a technology today? Let's take a look. So, at Stark Industries, this technology exists, but it's very large in size. In the movie, Tony Stark mentions that the reactor powering Stark Industries is based on this very technology. This makes sense because a fusion reactor, like a fission reactor, has a similar energy output. It generates a significant amount of electrical energy. The problem arises when Tony decides to place it in his chest. As of today, fusion reactors do exist. There's ITER, and several are under construction. However, the main limitation is that at the moment they consume more energy than they produce. Also, they are massive, about the size of a room. They rely on nuclear fusion, which is an extremely complex technology. How does nuclear fusion work? Combining light nuclei. The nuclei of light atoms, like hydrogen, mainly isotopes such as deuterium and tritium, come close to each other due to the immense energy present in the high-temperature plasma, overcoming electrostatic repulsion. Atomic nuclei have positive charges, so they repel each other due to the electrostatic force, the push between like charges. To make them close enough to fuse, an enormous amount of energy is required to make them move fast enough to overcome this repulsion and allow them to fuse. Energy release. When the nuclei combine, their total mass is slightly less than the sum of the individual nuclei. This missing mass is converted into energy according to Einstein's famous equation, E equals mc squared, releasing a tremendous amount of energy. Why is nuclear fusion important? Clean energy. Unlike nuclear fission, which produces radioactive waste, nuclear fusion produces minimal waste and does not create long-lived nuclear byproducts. The fusion products are generally isotopes of light elements like helium, which are not harmful to the environment. The current state of nuclear fusion projects like ITER, International Thermonuclear Experimental Reactor, are working to achieve controlled nuclear fusion. ITER is an experimental reactor under construction in France, aiming to demonstrate that nuclear fusion can be used as a sustainable energy source. While progress is promising, we are still far from creating a commercial fusion power plant that could be used on a large scale. In the movie, Iron Man uses palladium, which is much heavier than hydrogen. We could say that he has created a form of cold fusion. Essentially, in his reactor, he harnesses the decay of palladium. But is this something that can be done in real life? In fact, yes. But in reality, no one uses palladium for this purpose, because it has highly carcinogenic and toxic isotopes, as is actually depicted in the movie. particularly in Iron Man 2. However, producing 3 gigajoules per second of energy, as shown in the film, could theoretically work. The magnetic field in the movie works by attracting and keeping debris away. But could the Mark I be made in real life? The armor is made of steel and weighs more than 70 or 80 kilograms. It's like an exoskeleton that the military and certain agencies are already testing for specific purposes, and it's robotic. So yes, it is credible. In the second movie, we start to notice that palladium is toxic. Because of this, Tony Stark invents a new element that we know nothing about. All we know is that it's cooler than palladium, can do amazing things, and is not toxic. The propulsion systems are really fun, and we can compare them to plasma engines, the ion engines used in space exploration. These are highly complex devices that emit a series of ions and use them as thrust. An ion engine works by accelerating ions, atoms or molecules with an electric charge, and using their speed to generate thrust. Here are the main steps. Ionization. A gas, usually xenon, is ionized, meaning the atoms lose one or more electrons, becoming positively charged ions. Acceleration. The ions are accelerated by high-voltage electric fields. These fields push the ions to extremely high speeds. Ejection. The accelerated ions are expelled through a nozzle, creating thrust according to Newton's law. Every action has an equal and opposite reaction. By expelling ions, the engine generates thrust in the opposite direction. This type of engine is highly efficient for space travel, where a propellant that consumes little energy and can work over long periods is needed, but it produces relatively low thrust compared to traditional rocket engines. But how much does an ion weigh? The problem is that they weigh nothing. So the resulting force is tiny, it's about 100 newtons. How much can it hurt? And nothing, because the thrust is nothing. Iron Man uses it as if it were a normal chemical function engine, and it is not possible. In reality, it would have very little thrust. But in real life, there have been people who have used a propellant like Iron Man, but they are aeronautical jet engines, and they have a backpack filled with kerosene that lasts from 30 seconds to 2 and 3 minutes. Richard Browning and the jet suit. Richard Browning, a British engineer and entrepreneur, created a sort of flying armor called the gravity jet suit. Although it is not an armored suit like Iron Man's, his system is based on an exoskeleton equipped with jet engines that allow the pilot to fly. It has been described as the closest thing to Iron Man in real life, and Browning has tested his jet suit at various events, managing to fly and maneuver at low altitudes. However, it is clearly not a battlesuit like Stark's.
That's all for today. I hope my friend was clear and that he collaborates with us for the next videos. See you next video. That's all for today. Tell us if you like this format. See you soon.